In this tutorial, we will explore how Manim handles external files including images and SVGs. And in addition to that, we will also dive into how we can render equations or expressions in Manim. So, without further ado, let's jump right in. In Manim, what we have learned so far is to create MObjects, it involves assigning points at specific locations. But this becomes challenging when dealing with complex figures. Fortunately, ImageMobject simplifies this process by allowing us to easily incorporate images into our scenes. Before we start using ImageMobject, we need to tell Manim where to look for the images for the files. By setting a custom configuration, we can ensure that Manim can easily find image, SVG or sound files that we might use in the future. Let's go through the steps to set up a custom configuration. To start with, you need to open the terminal and head on to the directory of your Manim projects. And then type the command ManimGL --config. Follow the on-screen instructions about the related paths of the raster and vector images. If you are unsure of anything, you can press enter, which set the path to none for now. And don't worry, you can change that path later. Now, according to the official documentation of ManimGL, this should be the structure of your Manim directory. Notice the location of config.yml. The advantage of this approach of setting the custom configuration is that you can set different configurations for each project, for each of your folder. After completing this basic setup, Manim will know exactly where to look for the specified images. Let's head back to the editor and instantiate a variable img to ImageMobject and provide the name of the image file. One of the interesting aspects is that ImageMobject is a subclass of MObject, which means we can modify it just like any other MObject. We can move it, rotate it, or even scale it. Essentially, any method we apply to an MObject can also be applied to ImageMobject. Isn't it simple? The disadvantage of using such an approach is that we cannot modify the individual parts of the image. For instance, consider an image of this car. If we want to rotate its wheels or just try to change its color, it is not possible to achieve such functions. To enable those features, we can convert this image into an SVG file and use the class SVGMobject. This class takes a SVG file and transforms all the curves into MObject data points. Basically, SVGMobject gives you the feasibility to assign every part of this feature into its own variable, into its own subparts. This way, we can choose how to disassociate any SVG into its subparts and set the color or even rotate any of its subparts to make them more expressive. Moving on, SVGMobject has a subclass, StringMobject. And as the name says, the role is to display the text or strings on the canvas. Just as we saw earlier, the coordinate system is an abstract class, and so is this one. That is, StringMobject acts as a base class for all its subclasses, text and MarkupText. If you're familiar with the LaTeX format, you might know that the text renders as an SVG, which in Manim can be modified by an SVGMobject. Text is used to express mathematical equations or expressions in LaTeX format, and the MarkupText is designed for the non-LaTeX strings to be displayed on the canvas. MarkupText is completely based on Pango markup, which the Manim community documentation describes as a small markup language like HTML. Here's a basic example of using MarkupText. In line 4, we can see a basic markup format to render MarkupText. If you surround any word with the I tag, it will render it in the italic style as shown in the line 5. And to make the text bold, we can surround the word with the B tag as demonstrated in line 6. Although we rarely use MarkupText class, but its subclasses, text and code, they are very useful, and that's what I am most interested in. With the text class, we can choose our preferred font, we can use ligatures in the code, and we can style the text bold or italic or even emphasize it. In a nutshell, we will be using these main classes to display text in Manim. We have the text, which is for the mathematical expressions or equations, and then we have a subclass of text, which is text. That is for displaying normal text in LaTeX format. And the last, we have the text class, which is for easily using any font to render the text or the strings on the canvas. In addition to this, Manim also provides the functionality to colorize the strings. For the LaTeX format strings, that is for text and text classes, text to color map allows us to colorize each character. Take this spacetime curvature expression for instance. One way to set the color is by passing the specified symbol with the color as dictionary items. Just as we can see in the highlighted line, the argument text to color map specifies the pink color to the symbol G. Another way to animate the dynamic color property is by indexing the string. Imagine I want to change the color of Ricky tensor, which is this one. Well, in this case the index is 0, and that is pretty straightforward. However, counting the index of symbol like the cosmological constant, lambda here, can be very cumbersome. A better approach is to isolate the characters using the argument isolate, and passing the array of characters we need to isolate them, like lambda, the Ricky tensor, or maybe more. Just as I can isolate the cosmological constant, lambda here, and highlight it with the blue color, and even I can emphasize it on the canvas. Would you like to try setting the color of this symbol, the energy momentum tensor? We can even set the gradient of colors to the whole string by using the method setColorByGradient and pass an array of colors as argument. Now, moving on to the non-LaTeX category of string, text. It provides a wide range of parameters to modify the strings. Besides coloring with the argument T2C, we can make some of the words slant with the argument T2S. Or we can even change their weight, their font weight, with T2W argument. And moreover, we can even assign different fonts to different words with T2F argument. Isn't it amazing? And I'd like to take a moment to thank you for watching this video. I hope you learned something unique today, something new maybe. And if you did, do not forget to hit that like button. And I'll see you in the next video.